In this video, we're going to learn how to solve multi-step equations. This is part 1 of 2, and in this part, we're going to learn how to solve equations with variables just on one side of the equal sign. In part 2, we'll learn how to solve equations with variables on both sides. So let's get started with what our overall goal is. No matter what the equation is, our aim is always the same. We're trying to find the unknown amount by getting the variable we want on its own. So we can do this in a number of different ways. There's more than one way to solve an equation, and we'll see that in the examples below. One way to solve negative x minus 7/8 equals 3 is to start by adding 7/8 to both sides. By doing this, we isolate the variable on one side, that's negative x equals 3 and 7/8. And then we have one more step, which is to divide both sides by -1. And we end up with x equals -3 and 7/8. That's not the only way we could have started this problem, though. There's another route we could have taken. So for example, we could have multiplied both sides of the equation by 8. And doing this would clear out the fraction. So then we'd have negative 8x minus 7 equals 24. And then from there, it's just a regular two-step equation. Add 7 to both sides. We have negative 8x equals 31. And then divide by negative 8. That leaves us with x equals negative 31/8, which is also -3 and 7/8. So you can see there's more than one way we can jump into solving an equation. Your task would be to decide what you think the most efficient way is. So always try to think through the problem, what your first step is going to be before you do it. Don't just jump right in. In problem number 2, many people would start this problem off by distributing the -7. And if we do that, we end up with -7x minus 7 equals -28. We would then add 7 to both sides, leaving us with -7x equals -21. Then, of course, we'd divide by -7, leaving us with x equals 3. Now, while many of us have the distributive property kind of drilled into us, it's not the only way we could do this. So as I observed the problem, same problem, but on the right here, I noticed that the -7 and the -28 both have a factor of -7. So I could divide both sides by -7 first, instead of distributing. And that would leave me with x plus 1 equals 4. And then I could subtract 1 from each side. And as you can see, I end up with the same result, x equals 3. In the third problem, it looks a little more complicated. We have a little more to simplify. But again, many of us would distribute first, which kind of makes sense here since it would be a little harder possibly to divide both sides by -10 first. That might not be the best move here. Instead, if we distribute the -10 first, we've got -10x minus 20 minus 6 equals 46. We can then simplify over here, the -20 minus 6. That leaves us with -10x minus 26 equals 46. Of course, we can add 26 to both sides, leaving us with -10x equals 72. And then if we divide both sides by -10, we're left with x equals -72 over 10, which would then simplify to negative 36 fifths. Once again, there are many different ways I could have jumped into this problem. So while I distributed first on the left side here, in the second attempt at the problem, I could have added 6 to both sides as my first step, leaving me with negative 10x minus 20 equals 52. And then from there, add 20 to both sides. And you can see that we're going to end up basically with the same thing here. So that's negative 10x equals 72. Divide both sides by negative 10, which we know will leave us with x equals negative 36 fifths. So the main point here is to show you that there isn't just one way that you can solve an equation. There's multiple ways to jump in. You always want to think about your first step and try to pre-plan and think about which one's going to be the most efficient way to start. In our last problem here in part 1, we have the quantity of 10p plus 20 divided by 4, which is 35. Now, I'm only going to do this one way, and I think the way that many of us would go about this is we would undo the division by multiplying both sides by 4, leaving us with 10p plus 20 equals 140. We'd subtract 20 from both sides, leaving us with 10p equals 120. And then we divide both sides by 10, resulting in p equals 12. So that's the way that I started off this problem. I can think of another way we could have started this equation off to solve it. If you think you know what it is, please leave a comment down below.